Okay, ladies and gentlemen, as we continue from Supplement C, question number 4, and I've just put the pertinent data on my paper, but let me read it. The population of a small town in Georgia has shown a linear growth in the years from 1990 to 2003. Okay, again, linear means y equals mx plus b, so we know that that's why we can use the model. In 1990, the population was, and I have it right here, in 1990, the population was 13,462, and it has been growing at a rate of 235 people per year. Those are the things they give us. Part A says, write a linear equation expressing the population of this town as a function of t, where t is the number of years since 1990. So again, P of t is not just randomly the time. T is the number of years that have gone by since 1990. P is the population. I know it's a linear model, so I can write MT plus B. Y equals MX plus B. This is P of t equals MT plus B. Now, let's look up here for a minute at our data. In 1990, the population was 13,462. If I wrote that as an ordered pair, right, T goes in. T is the number of years since 1990. Well, if I'm in 1990, 0 years have gone by. And the population is 13,462. Well, guess what? I have just been given B. Whenever this is 0, this number is B. So they snuck B right in there, which is wonderful. Okay, one more time. In a linear model, anytime the input is 0, the output is B. And it's not a mystery. Don't memorize it. If you graph this point, where would it be? It would be on the y-axis, which is called the y-intercept. And the only reason it's on the y-axis is because this input value is 0. Okay? Now, next fact. The population has been growing at a rate of 235 people per year. Guess what that means, people? The change, which is the slope, is 235 people every 1 year. See that? So they just gave us the slope. The rate of change, which is what slope is, it's a constant rate of change. The rate of change is 235 over 1, but that's just weird to put the 1. But I wrote it for one reason. The rate of change is 235 people per every year, every 1 year. So the slope is 235. So what they did, here they gave us B, and in this wording, they just gave us M. So I know P of t equals, the slope was given to be 235. That was my constant rate of change. T is my input, the number of years since 1990, and then plus this. So this is my answer for part A. This is my function, my population function. P of t equals 235t plus 13,462. Okay, part B wants to know if the town continues to experience this linear increase, assuming that this model perpetuates, sometimes it changes, what will the population be in 2006? Well, let's think that through. In 2006, what we have to think about, time starts in 1990. In 2006, that would be 16 years. If I want to know what the population would be in 16 years, I put 16 into my model. P of 16 is 235 times 16 plus 13,462. And when I go to my calculator and I do that computation, I come out with an answer of 17,222 people. So basically in this problem, this was much easier than problem 3. In this problem, they virtually just gave us B, but they instantly gave us slope. So anytime you see something is growing at a rate of, or the rate of change of something in a linear model is something, they've just given you the slope. And if they told you that the town had, if it had said the rate of decline was 235, then my slope would have been negative 235. So it all ties in really beautifully, okay? This stuff is beautiful. All right, we're done with that one.